Hello students, welcome to this video lecture. In this video lecture we will discuss about Core 7 first unit topic, that is classification of first order equation. Okay, let us write this one. Classification of first order equation. Okay, partial differential equation. This is your first topic. First topic is quasi-linear equation. This is the first topic, that is quasi-linear equation. Let us write the definition of this equation. First order quasi-linear equation can be written as f of x comma y u ux uy, where, and this can be written as, here we write the properties, that is x y r belongs to the domain, and this domain from R2. Okay, this domain is the proper subset of R2. R2 means it is a two-dimensional plane, and in two dimension we have x y as a coordinate. Okay, in two dimension here, where x y are the independent variable. Okay, where x y are the independent variable. And what is u? U is a unknown function. U is a unknown function. Okay, what is the value of ux and uy? So it can be written as ux is equals to du by dx and uy is equals to du by dy. Okay, so it means that ux, that is a function of u, uy function of u also, because u contains both x and y. Here in the first part, f contains x and y. This is the f part, this is the u part. Okay, is that clear? Let us consider this ux uy as pq. Let us consider ux is equals to p and uy is equals to q. Then our equation becomes, taking this one as first equation, okay, putting this ux and uy value in the first equation, hence equation 1 can be written as how this equation will be x y u. In the place of ux we will have this p, and in the place of uy we also have q. Okay, so here this is the equation of quasi-linear in R2. Okay, so it means that this is the equation in R2. So how can we write a equation where the domain is a proper subset of R3? Okay, if the domain is a proper subset of R3 and the coordinate are x, y and z, then for the third individual variable we can write the equation will be looks like f of x, y and z, comma u, ux, uy and uz. Is that clear, students? I hope you understand. If we take this ux as p, uy is equals to q and uz is equals to r, then our equation will be looks like f x y z u p q r. Okay students, so this is the quasi-linear equation for third degree. Okay, so here the coordinates are 3, x y z u. Okay, u is a function, so this is ux, uy and uz in the form of p q r. Okay, so this is all about the quasi-linear equation where we have the unknown variable with the function. Now let us discuss the first order linear differential equation, the standard equation. Okay, so by focusing the standard equation we will also solve some numericals. So before going to the numericals, we have the standard equation. Okay, let me write the definition. First order linear differential equation. So students, this is a first order linear differential equation. The standard form of the first order linear differential equation can be written as a as a coefficient and x y as a variable. Okay, so with respect to x we have ux, u is the unknown function we know, and with respect to x, next b is another coefficient, and for the same variable, that is x and y, and with respect to y it will be uy. U is the unknown function, and with respect to y, that is partially differentiate this, and another function. Okay, so c is another coefficient, and x, y, and this one is u. Okay, and uz. Okay, and this is equals to d of x y. Okay, so this is the right side, this is the left hand side. We have left hand side, this one is the left hand side, and this one is in right hand side. Is that correct, student? Okay, so focusing on the standard equation, we will solve some numericals. Students, now let us discuss some numericals based on the standard equation of first order linear differential equation, and the question is about show that a family of spheres x square plus y square plus g minus c bracket square is equals to r square satisfy the first order linear differential equation yp minus xq is equals to 0. Okay, so our function is this one is our function, and we have to satisfy this linear differential equation. Okay, so for that what we do, solution here. So the given equation can be written as x square plus y square plus z minus c bracket square is equals to r square. Now what we do, we will partially differentiating this function. Okay, both sides. So it means that partially, when we partially differentiate the function with respect to x and y, so it will be, now how can I write this one, differentiating both sides with respect to x. Okay, differentiating this function, differentiating this equation 1 both sides with respect to x. So now if we differentiate this function with respect to x, so it will be dy dx of what is on the right left side. Okay, so x square plus y square plus z minus c square, okay, bracket close, is equals to d by dx of r square. This is equals to, okay, so d by dx of x square, here we can write directly, that is 2x, okay, and d by dx of y square, it will be, what is that, in partial differential equation, if we differentiate a function with respect to x, then the y term will be 0, okay, so d by dx of y square will be 0, okay. So I am not writing this, I am writing directly, I am coming to this one, because this one is 0, we have this one as 0, d by dx of y square is 0 plus d by dx of z minus c square, okay, so it will be 2 z minus c d z by dx is equals to d by dx of r square is 0, okay. Why I am writing here, because as students, you may have a question in particular these cases, why sir this g minus c square we got the derivative here, okay. So the main thing is, g is a function which contain both x and y, okay. In most probable cases, okay, z is equal to fxy, you all know z is equal to fxy, so z is a function that contain both x and y, so that here we don't know what z contains, either x or y, so here we did the derivative, okay. So it may not have any x term, okay, but z contains x and y, so that we got the derivative here, that is 2 z minus c dz by dx is equals to 0. So now let us discuss, okay, so move to the next step. Here in this step we have 2 in both sides, okay, so this side and this side, so taking 2 as common, we will have x plus g minus c and dz by dx, okay, is equals to 0, okay. So now x plus z minus c dz by dx is equals to how much, this is 0, because this 2 is a multiplier of this function, okay, so 2 will be vanishes, okay, 0 by 2, this will be 0, so x plus g minus c dz by dx is equals to 0. dz by dx is treated as p, okay, because we have ux is equals to p, and this is the part, we have dz by dx is equals to p, okay, and dz by dy is equals to q, that is for sure. So we can write x plus g minus c, and in the place of dz by dx we can write this is as a p, which is equals to 0. So from the equation here we write the implies symbol, okay. So from this we will get z minus c of p is equals to minus of x, is that correct, student? So now we can write z minus c is equal to minus x by p. So this is the equation 1. So when we will partially differentiate this equation 1, we will get this equation, okay. Now coming to the next, that is differentiating both sides with respect to y, differentiating partially, students, I am forgetting here, differentiating partially both sides with respect to x, okay. So now differentiating okay, so differentiating partially both sides with respect to y, so your equation will be looks like del y of, and the equation are x square plus y square plus g minus c bracket square and bracket close here is equals to dy dy of r square. Okay, so what is next? Dy dy of x square, it will be 0. Okay, and here dy dy of y square, it will be 2y plus, and we can also take the derivative. Okay, because z also containing x and y, in terms of x and y we can take the derivative of this function. So what will with that? 2 of g minus c, and here dzy dy. Okay students, so now what is next? From this function we have 2 as a common. We will have 5 plus g minus c and dzy dy. So now 2 and this is equals to 0. So now equals to 0. Okay, because the derivative of r square is 0. I forgot, here we write 0 0. Okay, so now it will be y plus g minus c, taking this as q. Okay, this is equals to 0. So it means g minus c of q is equals to minus y, and g minus c is equals to minus y by q, and this is equation number 2. Sorry, we have equation this one is equation 1, this one is equation 2, and this one is equation 3. Okay, so here we got the value for x and y. When we differentiate partially in equation 1, we got 2 value. Okay, so now we will compare both the equation, that is 2 and 3. So in the first equation we have g minus c is equals to minus x by p, and here in the third equation we have g minus c is equals to minus y by q. So comparing equation 2 and 3. Okay, if we compare this two equation, that is 2 and 3, so here in both the equation we have g minus c as a common. Okay, in the first equation you can see this g minus c is common. Okay, g minus c, and also in the third equation we have g minus c. So we can write as minus x by p is equals to g minus c, which is also equals to minus y by q. Is that correct, student? If I write this, okay, so now it means that minus x by p is equals to minus y by q. Okay, so according to this line, okay, as minus x by p is equals to g minus c, and this minus y by q also g minus c. So from the above hypothesis, from this hypothesis we can conclude that minus x by p is equals to minus y by q. Is that correct, student? Okay, so cross multiplying this, it will be minus of xq is equals to minus of yp. Is that correct, student? So now cancelling this minus from both the side, and this will be xq is equals to yp. Okay, so this taking this yp from left side, from right to left side, it will be xq minus yp is equals to 0. Is that correct, student? So it is same as yp minus xq is equals to 0. Okay, students. and here we have the same line. It is given yp minus xq is equals to 0, and here we got the same value, yp minus xq is equals to 0. Okay, so hence the partial differential equation for first order linear differential equation is verified. Okay, is verified, that is yp minus xq is equals to 0. Okay, and this is your answer. I hope you understand, student.